Hello, Year 11. This session today is on the topic of crude oil, which is in the organic chemistry section. Can you go into silent solo for 10 minutes for question 1? And after that 10 minutes, please resume this video. Okay, silent solo, 10 minutes, question 1, off you go. Okay, I hope you've had your 10 minutes now. You've had a chance to have a go at the question. Let's see how you've got on. So as mentioned, this topic is about crude oil, specifically in the organic chemistry topic. This comes in paper 2 on chemistry. So crude oil is said to be a mixture of hydrocarbons. Now, remind you, a mixture is two substances not bonded together. However, it's made up of hydrocarbons. That hydrocarbon is a molecule. It's a molecule made specifically of hydrogen and carbon. So that is a molecule. Now you can have more or less hydrogens and carbons, so they can be quite large molecules and quite short ones, hence the mixture. It's a mixture of large and short and medium-sized hydrocarbons. It then talks about the hydrocarbons, so those molecules made from carbon and hydrogen, in crude oil are separated into fractions. Now, fractions, it just means pretty much this does in maths. So the whole of the crude oil is separated out into little chunks. In this particular case, it just means chunks with similar properties. That might be similar length molecules that have the same similar boiling points, or similar length molecules that have similar flammability, as in how well they combust, or they might have similar viscosities, as in how thick and easy they can run. So that's what we mean by similar properties. So we've got these molecules of different lengths mixed together, and we want to separate them into chunks with similar sizes, called fractions, and we're going to use something called fractional distillation to do this. Now, fractional distillation is a physical separation technique, as in no bonds are going to be broken. So one hydrocarbon molecule is going to stay as a molecule and move away from another one. So no bonds are broken here. To do that, distillation involves two specific changes of state. It's going to involve evaporation and condensation. Okay, so in a little rhyme, distillation is a combination of evaporation and condensation. So that might work for you as a way to memorize that. Now, I know from past experience, not everybody's going to remember what evaporation and condensation are, so I just want to remind you about that. So we've got 3 states: solid, liquid, and gas. And the evaporation and condensation come between the liquid and the gas. So if you take a liquid and you turn it into a gas, that is your evaporation. If you have a gas and you turn it back to a liquid, that is your condensation. Now, those appear at exactly the same temperature. So just depending whether you go up or down in temperature, at a set temperature, a liquid will evaporate or boil into a gas, and a gas will condense back to a liquid. And at that point, it's called its boiling point. So that is the temperature at which that state change occurs. Now, another topic in year 11 is knowing that that's a very specific point if it's a pure substance, but this is a mixture. So this will be a range of boiling points. So, for example, 210 to 212, for example. All right, so we've got lots of information now, and it now mentions what figure 1 is. So figure 1 is this diagram. It shows a fractional distillation column. So it's the column, it's a place, it's a location where fractional distillation takes place, where evaporation and condensation take place. So we carry on down. It mentions crude oil vapor is passed into the column. And that vapor is a big clue, because it's telling you it's a gas. So as it enters, it's a gas. Now, I would point out, because it's going to help you later on, that does really identify that it's probably pretty hot down here if it's a gas when it enters. What it wants to know is each fraction does something at a different level. Well, we already know what this is, because we already know fractional distillation is evaporation and condensation. Now, if it's already a gas, that means evaporation has already been done. It's already been turned into a gas. So now we just wait for condensation for it to turn back to a liquid. So that really narrows our choices. And that will happen at very specific boiling points for different lengths of hydrocarbons. So very small hydrocarbons, that will condense right at the top of that column. Very large hydrocarbons will condense right the way at the bottom. Hence how you separate into fractions. Let's have a look at part B. It then says, why do the fractions separate? Now, I have mentioned that a couple of times, but it is worth pointing out that every single one of these statements is factually correct about a fraction. So every fraction does have a different boiling point. Every fraction does have different flammability. Every fraction does have different boiling and melting points, and they do have different viscosities, as in how thick or runny something is. But only one of them is relevant to distillation. So again, if we go back, distillation is a combination of evaporation and condensation that takes place at boiling point. So only the boiling point is relevant at this point. Okay. So just because I haven't ticked the others doesn't mean they're not correct about fractions, but only that one is relevant to fractional distillation. Now, the next diagram shows you what's called a molly-mod kit. A molly-mod kit is little plastic balls and sticks that stick together to represent a molecule. Now, most of you will have had a go at these or seen your teacher use them. But just in case you haven't, let's just make these very clear for you. So these little white balls here, these represent hydrogen atoms. The black ones represent carbon atoms. Remember, this is a hydrocarbon. And the little grey sticks in between represent covalent bonds. Remember, these are non-metals, and non-metals bond covalently. So I can see straight away that there are 1, 2, 3 blacks. So there are 3 carbons. There are 1, 2, 3, 4, 5, 6, 7, 8 whites. So there's 8 hydrogens. Now, it'd have been nice if they asked me for the formula, because I've just done that, but they didn't ask me for the name. Now, at this point, there's no other way around this than memorising them. Now, I know there's a lot of acronyms. This may or may not help you. It's certainly how I memorised it. So there is a way to memorise the name of the first 4 alkanes, which is the ones you can be asked. It sounds a little weird, but it is monkeys eat peeled bananas. We take the first letter of each of those. Now, we do have to remember the alkanes that end in ane. So we have to M, methane. Eat, E, ethane. P, propane. B, butane. Now, obviously, there's aspects that you have to memorise, but at least that helps you remember them in order. So as I've got 1, 2, 3 carbons, then the name of this molecule is propane. You might be interested to know the year this exam was sat, very few students got that right. Okay? You're not going to be those students, you're going to get it right this year. Moving on down, it then mentions the smallest of the alkanes, the methane, the one with 1 carbon in. But however, it asks you for the general formula. Now, general formula is just the ratio of carbons to hydrogens. So if I have this many carbons, how many hydrogens am I going to be able to have? Now, many of you will just memorise this, and that's absolutely fine, and you should do. If, however, your brain just wipes in the middle of the exam and you just cannot remember it, it's dead easy to work out. If I go back and look at the formula of propane, C3H8. That's an alkane, it said it was. Like so. There are 3 carbons for every 8 hydrogens. I can apply each of these formulas to see if it works. So if I use this formula, N is the number of carbons, 3. So that would be C3H, and it's also in there, also 3. That's not the same as that one. If I try this one, see the N, that's a 3. And then it's H2N, so I've got to multiply the 3 by 2, which is giving me 6. Nope, I should have 8. Here, my Cn, so C3. My H2N, so that's 2 times 3 is 6 minus 2 is 4. Not that. At this point, you're really hoping it's the last one, but we'll double check. So Cn, so that my N is 3. H2N, so 2 times 3 is 6. Plus that 2 gives me the 8. And that gives me the confidence. As I said, most people generally memorise that, but if you can't, you could just work it out, the way I have. And moving on to the next one. I know many of your teachers will have told you this. Balancing equations are very time consuming. They're only worth 1 mark. Give it a go. Never leave it blank. But you might want to come back to it towards the end of the exam when you've got, and you know how much time you've got to play with it. And there's always the old backup, stick a number 2 in if you're really unsure. But let's see if we can do it properly first, because that's your backup plan, not your first plan. Now, if you ever have to do a balanced equation where you've got carbons, hydrogens, and oxygens, my suggestion is do the carbons first, then we'll balance the hydrogens, then balance the oxygens. It's much easier. So to balance, that's the conservation of mass of law, sorry. So at that point, we're just saying that you shouldn't make or destroy any matter. So we should have the same number of carbons and hydrogens that we start with. We're just rearranging them, but they're still all there at the end. So currently, I appear to have 1 carbon, 4 hydrogens, and 2 oxygens on this side of the equation before the arrow. After the arrow, I have 1 carbon, I've got 2 oxygens there, 2 hydrogens, and 1 oxygen. So straight away, I can see my carbons are balanced. So I don't have to worry about my carbons. That one's done. My hydrogens, however, are not. I have 4 hydrogens here, but only 2 there. So I can only put numbers in front, and that doubles everything that follows. So if I put 2 here, I have now got 2 lots of 2 H2Os. So there was 2 H's now in 1 molecule, so there's going to be 4 lots of H's and 2 O's in 2 molecules. The good news is my H's are now balanced. So now my next section is to go and look at the oxygen. And you can see there's 4 oxygens now on this side. There are, however, only 2 oxygens on this side. So all I have to do is put a 2 there. 2 times 2 is 4. Now I have my oxygens balanced as well. And not surprisingly, it was also 2s. The final one was asking you how you test for an alkene using a reagent. A reagent is just the name of the chemical that you use to do the test. So let's go and have a look at your options you have. So you've got 4 options here, and every single one of them is a reagent for a test for something, and they're all ones you need to know. So it's worth having a look at them as we go through these. So anhydrous without water, copper sulfate. You learnt this one you did about reversible reactions. So this one actually tests for water. And this is the one that's the white powder that turns into the blue crystals. But unfortunately, it isn't testing for an alkane. Bromine water, I'm going to come back to. Damp litmus paper. This is the one that was on your mock. So quite a few people, this is the one that most people forgot. This one tests for chlorine. Okay. So that one, it depends which type of litmus paper you've got, because I didn't name it here. So it's either pink or blue. It's usually blue. And it decolorizes because chlorine is in bleach, so it takes colour away, so it turns that white. Lime water, generally speaking, most people are okay with this one. This one tests for carbon dioxide. And that goes cloudy. So none of those tests for an alkane. Obviously, it's the bromine water. So the bromine water does test for an alkane. If you were ever to ask you the colour change, because you do need to know this, it goes from orange to colourless. It decolorizes it. Now, I'm going to ask you now to have a go, any remaining time or homework, to have a go at just the question 2 to see if you can now apply the same principles and answers to the second question, which is very similar. The only one that's a little different that I haven't gone through is part A. You do need to go and figure out how crude oil was made. So if you're not sure about that one, make sure you double check that one before you leave your tutor today. All right, good luck, folks, and off you go with question 2. Bye.